still the front page already?
Yes. All right, so we're continuing with density. All right, so we rewrote the density formula for, we solved for mass. So if we were looking for the mass rather than the density, we could take the volume times the density. We're going to do the same thing now, but we're going to rewrite the volume, and then we'll solve the problem up above there. All right, so second part of this, you can reach the marker. Thanks. All right, so density, still going to start with density equals mass divided by volume. All right, and again, we're going to multiply both sides by volume. So we have volume times density equals mass divided by volume times volume. All right, that'll get the volume out of the denominator there, but it's still not isolated.
Are you rewriting that?
Yes.
Oh, okay.
Well, it's a new, well, we're solving for volume this time.
Oh, okay.
So now we have volume times density. And we're going to divide both sides by density because we're solving for volume here. Equals mass divided by density. So the densities will cancel. And so now we've rewritten this in we solve for volume. So we have volume equals mass divided by density. So if what we're looking for is volume, not density, we could take the mass and divide by the density, and we would have the volume. Let's see what the problem above is asking us to find. So gold has a density of 19.32 grams per cubic centimeter. Rewrite the density equation for each of the following. So we want to actually so we've rewritten it in terms of just mass and volume. Let's rewrite it in terms of this particular problem, right? So we've rewritten it in general. Let's rewrite it for the particular problem. All right, so let's identify what we know. We have, so our mass is what we are looking for. We've got volume. So cubic centimeter, that's volume. So we don't know what mass is. Our density is given to us, that's 19.32. And then our volume is per cubic centimeter, so that's per 1 centimeter. So the volume would be 1 cm cubed. Okay. All right, so now we could solve for our missing thing. We'll rewrite since it says rewrite the density equation for each of the following. So for mass, let's do this one first. Actually, we'll do either one of them. So mass is equal to the volume times the density. So if we take 19.32 times 1 centimeter cubed, and actually, I forgot to do one thing. What was the one thing I forgot for density?
Putting
Units, yeah. I forgot to put in the grams per centimeters cubed. So this would be 19.32 grams per centimeter cubed times our volume, which was 1 centimeter cubed. So now, if we multiply 19.32 grams per centimeter cubed by 1 centimeter cubed, what would we get as our volume? Excuse me, not our volume, our mass, excuse me, our mass. So what would our mass be?
19.32 grams.
Yeah.
Centimeters.
Well, the centimeters cubed will cancel.
Oh, yeah.
So our mass is just 19.32 grams. So you could use these equations to solve for mass if you know volume and density. Or, actually I guess I should write it next to the equation. Or you could just write density equals mass times volume and follow these same steps to isolate your number. So I didn't have to isolate mass first. I could have just plugged the values in and then solved. Right? And then volume we have, I'll rewrite it in terms of volume. So volume here was the 1 centimeter cubed. And we didn't know the mass before, but now we do. The mass is 19.32 grams. And our volume was 1 centimeter cubed. And so our here it's just kind of showing you, oops, did I put the right thing in there? Mass, oops, no I didn't. I put it backwards. Ooh. Sorry about that. Mass times density, I'm reading upside down. Mass was, oh no, I had the right thing. I said the right, did I have the right? I had the wrong, I plugged in the wrong thing for density, that's what I did. So it was 19.32 grams per centimeter cubed divided by the 19.32 grams. So if we didn't know volume, for instance, and we took the mass and divided it by the density, we would get this as an answer because the grams would cancel out and this would just be 1 centimeter cubed. So you can use these equations to solve for mass and volume. Or you can just use the density and isolate. Right? So sometimes we'll be looking for different things. So this one was just a little bit different because we solved for some variables, just so you can see how the equations would work. Any questions on this one? Yeah. So now we'd be on the other side. Yeah, the actual other side, not the one that was photocopied wrong. Yeah, so I'll give you the other page. Everyone got one, right, of the other page?
So in the part in the red, would that be the answer to the question?
Yeah, so it probably would be that we were solving for volume. And so we'd probably have volume equals this, and then we would cancel out the 19.32 and the grams, and we'd be left with 1 centimeter cubed, which is what we have over here.
So if we already know the volume, we would just put volume equals 1 centimeter cubed?
Right, well, you wouldn't be solving for volume if you already know it. Okay. Good? Everyone good? Okay. All right, so let's solve some problems. This one is in your notes on the other side. A block of wood has a length of 10.2 centimeters, a width of 6 centimeters, and a height of 4.1 centimeters. Let's draw out our block of wood. All right, so that's going to be a rectangular prism. All right, so we have a length of 10.2. We have centimeters, I should put units there. And we have a width of 6 centimeters. And then we have a height of 4.1 centimeters. Now, on a rectangular prism, it does not matter which is the base. However, I always make the bottom the base. On our other prisms, triangular prism, any other prism, it would matter. All right, so first thing we have to do, notice we need to find the volume. We're not given the volume. Right? So remember, our volume is equal to the area of the base times the height of the prism. So let's find these two things. How do I find the area of the base? Anybody at the yellow table? Right, So that's going to give us 60 and then 1.2. So 61.2. And that was centimeters cubed. What's the height of this prism?
Will it be squared?
Oh, I'm sorry, yes. I'm thinking ahead to volume. Thank you. How about the height of this prism? Green 3.
The height would be 4.1.
So we have 4.1 centimeters. And then if someone wouldn't mind multiplying for me, 61.2 times 4.1.
250.92.
250.19.
0.92. 0.92.
Oh, 0.92. And that, now it's centimeters cubed. So now we have our volume. We're looking for the density of the wood, so that means we have to have our mass. What's the mass of this piece of wood? Yellow 2. Yeah, so that's given to us right there. Sometimes you have to solve a little bit for it. It might be that we have to do some work to get the mass, not on this one. So that means our density is going to be our mass divided by our volume. And so density is 179 divided by 250.92. And our units would be grams per centimeter cubed. What does that simplify out to as a single decimal? I mean, I'm sorry, as a decimal number as opposed to a fraction. 0.7133? And our units would be grams per centimeters cubed. The mass units divided by the volume units. You could also change that to grams per milliliter, but it really does not matter. It's fine the way it is. Any questions on this one? Okay, so we will be using our volume formulas to find our density sometimes. Ready for the next one? Hey. No, leave it. Someone say leave it. Good, good. Okay, everyone good? So the density of silver is 10.49 grams per centimeters cubed. If a sample of pure silver has a volume of 12.993 cubic centimeters, what's its mass? Now let's say you're taking a test, you don't remember that other formula, right? You could just simply write it as density equals mass divided by volume. And just plug in your values and solve for the variable. All right, so it's not like you have to use those other formulas. You can just use the density formula if that's easier for you just to keep one in your head. Right. So and then we're just going to plug in the values. 10.49 grams per centimeters cubed is equal to the mass is what we're looking for. So let's just put an M there, and our volume is 12.993 centimeters cubed. And now you can see what to do, right? You'd multiply both sides by 12.993 centimeters cubed, right? So it's not like you have to remember the other formula. It's fine if you don't. So this one here is 10.49. I kind of wrote it like this, but technically it's really like that. So you can see that the centimeters cubed will cancel. So our answer is just going to be in grams, right? The 2 centimeters cubes will cancel. Somebody multiply that out for me in the calculator.
36.19. Do you just want me to give you that or the whole number?
The whole number.
Okay. 657.
So 0.29657?
Yes.
Yeah. Yeah, because this was an exact answer, so it's not a rounded answer at all. Let's include all the decimals. If we get this, 33333, then we can cut it off. But this one is an exact answer. And that would be grams is our mass. And I'm going to put mass. Any questions on this one?
Pretty simple.
Calculator is really going to be necessary on these problems. Otherwise, because a lot of times the multiplication and division is a little on the tedious side. So you're going to want a calculator. Let's look at the next one. So this one's in your notes. We want to calculate the density of the rectangular prism below, weighing 936 grams. Right, so it doesn't tell you to find volume, but you have to remember that you need volume to find density. And we don't have volume. However, we have the figure, and we have its value, so we can find its volume. This 14 centimeters here is right smack in the middle there. It is perpendicular to the base. That is our height. Remember, the volume for a pyramid is going to be 1/3 the area of the base times the height. I've already given you the height, right? So the height, I'll just kind of put it here. The height here is 14 centimeters. Let's find the area of the base. All right, so how do I find the area of the base? Yellow 3. Yep. So the area of our base here is going to be 60 plus 18, yep, 78. So our volume is going to be 1/3 times 78 times 14. The 78 is divisible by 3 because 7 plus 8 is 15. And 15 is divisible by 3, so is 78. So that would go in 23 times, right? 26. Oh, 26. Why did I put 6? 3. Thank you. I know, I'm thinking of, I guess, first half of me divided by 3 and the second half of me divided by 6. 26 times. Because we'd have 3 goes into 7 twice, we'd have 18 as a leftover. And so it would go in 6 times. I don't know why I put down 3. Thank you. So we have 26 times 14. And if you want to just multiply that for me. 364. So that'd be 364 centimeters cubed. Right, I'm going to have, and we know what the weight is, right? So our mass, it says weighing, that's our mass. So our mass is 936 grams. And I'm going to have somebody else here set up the density for me. All right, so what would the density be? Throw all these. Green 5. How would I set that up?
936 grams over 364 centimeters.
And what would this be as a decimal? Someone?
2.571.
2.571 grams per centimeters cubed. So once we find the density, it's easy to compare objects and be able to look at, for instance, which one might float which would be more likely to float than the other objects, which objects would sink, which ones have a heavier density.
So if it's an exact number, you're gonna write down all the numbers.
Yeah. And it's always okay to include more. What was more dense, this rectangular pyramid or a block of wood?
This pyramid.
Yeah. That one was 2.571, and our block of wood was not very dense. Wood floats. Wood's pretty good at floating for the most part. Now, this probably is not going to float. Whatever this is made of. Probably maybe metal. I don't know. Oops, got to erase this one. And I'm going to guess I forgot to erase all the others. So this is a good time anyway to end this podcast and start a new one so it's not too long. So, whoops.